I opened a basic Windows program in x64dbg, and right there I found a login logic. CMP EAX 539. JNE wrong password. Shows JNE login in CMP EAX 539. That's the line where the program decides if you're in or out. But here's the crazy part. You don't need to be a hacker or a coder to understand this. Today, I'll show you how to read real x86 assembly, even if you're just getting started, and how those simple instructions unlock everything from login screens to software cracking. Welcome to HackByte. In this video, we're breaking down what EAX actually means, the 7 essential x86 instructions you'll see in nearly every program, and how reverse engineers use them to modify, patch, and even bypass code. Let's get into it. So, what is EAX? EAX is a register. Think of it like the CPU's clipboard. Whenever the processor needs to store a value, like a user input or a calculation, it gets dropped into EAX. You'll see EAX everywhere. It holds return values from functions, it stores password checks, and is used for comparisons, jumps, and more. Let's break down the core instructions that power most of what you reverse. First, we have move. You'll see move EAX, 5. This copies the number 5 into the EAX register. And then you have things like move EAX with an open and close bracket showing user input. This loads the user's memory into EAX. So here we have our EAX box and our CPU clipboard. We're going to take 5 and put it into the clipboard. This could be whatever is decided in the code. We can also put user input. So if I decide to put 6, it will move 6 into the EAX register. Next, we have CMP. CMP compares values. It checks, is EAX equal to 1337? Here, we're going to have CMP EAX, 1337. This doesn't store the result. It sets a temporary flag to go back and look what the code is required to have or a license. Next, we have conditional jumps. We have JE, JNE, JG, and JL. You're probably wondering what each of these means, but don't worry. JE stands for jump if equal to, JNE stands for jump if not equal to, JG is jump if greater than, and JL is jump if less than. We would normally have things like JNE wrong password. So if the password is entered incorrectly, we would jump if it's not equal to it. Then there's unconditional jump. So this would be JMP access granted. This doesn't check anything, it doesn't ask questions, it just goes. We would have our JMP access granted, and this just moves the user's input. So if you open up a program and you enter a password, we know that it's correct. It will move to the next command. Next is the call function. This runs a function. So we have call check password. It jumps to another piece of code, runs it, and makes sure that it goes to the jump condition, runs everything, and then it'll come back. And then we go to our return function. It returns back to where you left off. You'll see call and return used constantly for structure. Here we have our push and pop. And this is stack control. So we'll have push EAX and pop EAX. This saves and restores values like a temporary memory shelf. Push stores and pop retrieves. So we would have our push EAX, and then we'll have our EAX in our stack, and then this moves it away, and stores it temporarily, up until pop is called and retrieves the code. Here we have our pop EAX, which will just make our little clipboard again, and have EAX, and then it'll put it back on top of the stack. Let's break this down into a real-world example from our demo program. We have move EAX user input, compare EAX to 1337, jump not equal to wrong password, call grant access, jump end. If it's the wrong password, we're going to call deny access. Then we're going to go end and then return. So we would continue wherever we left off. So this code checks if your input is equal to 1337. If it does, it calls grant access. If not, it calls deny access. And if we want to bypass this, we'd simply change JNE to JMP. Let's say the program calls a function to validate your license. We have call validate license, compare EAX to 1, JNE, unlock full version. Here are the results of a validate license. It's placed into EAX. If it equals 1, the program unlocks full features. This is how you find licenses, trial limits, and even time-based restrictions. Here we have our stack, ESP and EBP. At a deeper level, you'll see ESP and EBP, and also more stack frames. Just remember, ESP is points to the top of the stack, EBP is used for stack frames. Push and pop manage temporary values like function arguments. We'll cover full stack frame tracing in a future video. Here's a visual flow of the login program that we have. So we have our user input. We're going to go to move EAX into our input. And then we're going to compare EAX to 1337. If it is yes, we are going to call grant access. And then we're going to return. If it is no, then we're going to go call deny access and then return. So now you know what EAX is, how CMP and JMP decide the path, the 7 most common instructions in reverse engineering, and how to analyze real login logic. Download the free cheat sheet below. It summarizes everything in this video for quick reference. If this helped you, like the video and subscribe, because next time I'll show you how to modify and patch a real Windows program using the same techniques. This is HackByte, and this is how we learned software really works.